Okay, girls, so you need to listen and watch to the two first intro to integration and intro to integration 2 before you look at this one. So what I'm going to be doing in this video is just having a look at question 2 on page 69. So I'm hoping what you have done, sorry, I know you can see Rhonda and I'm sorry, but she can't be left alone because she just chews everything up. So that's why she's in with me. So the yeah, question 1. Let me know how you got on with it. If there's anything you didn't get, let me know and I can help you with it. Question 2, I'm just going to, go across. By the way, I'm still in the same clothes because it's still the same day. It's not that I haven't showered and changed. I'm making this video the same as the other day. Okay, so question 2 says find each of these integrals. Now, just to remind you, what that means is we're reversing the process of differentiation, okay? So instead of reducing the power by 1 and multiplying by it, we are increasing the power by 1 and dividing by it, and then adding our important c on. So with question 2, an important part of it might be, I'm thinking, your index rules. Okay, so have them open so you can see them. So I'm just going to pick one of these to do. So, yeah, if I just pick the very first one, it's asking you to integrate x to the power minus 2 and has the little dx. And remember, that dx is always going to be there, okay? So if we go by what they're asking me to do by the rule, we're going to increase the power by 1. If you increase minus 2 by 1, you'll get x to the power of minus 1. And then what you're going to do is you're going to be dividing by minus 1, okay? And then add on your c, okay? So that's x to the power of minus 1 over minus 1. So you've increased the power by 1 and divided by that number, and then adding on c. Now, if you kind of make this a little bit neater, that will be, well, I'll leave it as x to the power minus 1. The divided by minus 1 just means the whole thing will have a minus in front of it, okay? Now, if you remember back to index rules, and when we did any differentiation, we wouldn't have given our answer back like that. We would have always used maybe an index rule to make, we wouldn't want to give it back as a minus power. So just think back to your rule. And the rule I'm thinking of here is, and I'll just put it on the side here, a to the power of minus p is equal to 1 over a to the power of p. And they're in your index rules. So if you use that here, you could say that the answer to this will be minus 1 over x to the power of 1, which is just the same as having minus 1 over x. Now, what have I forgotten? My plus c. See, it's very easy to forget it, so I'm popping it in there. Okay? Now, that's the first part done. I'm just going to pick another one that might be, I'm going to pick out v, for example. So part v has integrate and it is the square root of x. 1 second. So with this one, again, think back to your index rules. And the square root is an important one. The square root of anything is the same as that to the power of a half, okay? It's one I think it's good to learn off, okay? So just before I go about actually, what am I trying to say? Before I actually integrate it, I'm going to just use the fact that we know that the square root of a is a to the power of a half. I'm going to do that so I can integrate it. So this is the same as saying x to the power of a half dx. Okay, I haven't integrated it, I've just written it in a different form. I hope that looks like a half there. Now I'm going to integrate it. So increase that power by 1. You will tell me that becomes, well, a half plus 1 is 1.5, or 3 over 2. And then divide by whatever this power is, which is 3 over 2. And remember, plus c. And if you are wondering what the c is about, go back to the first introduction to integration. Okay. Now, this is essentially it integrated, but what I can do now is tidy it up again, kind of using any type of simplification or index rules. So firstly, the x to the power of 3 over 2, if you use the index rule, that is going to be the same as x. Now, you bring a root into it. This bit goes in here, so it's like 2. Now, do I need to write that 2 in? Not really, but I'm going to put it in there anyway. And it's cubed. Oh, sorry. Equals. And that's an index rule of basically using your power. This bit goes in there, and this goes to the power, okay? Now, that's over 3 over 2, which is the same, if you're dividing by a fraction, it's the same as multiplying by the reciprocal of it. So, like KFC, you're dividing by a fraction. So that's the same as timesing it by 2 over 3, okay, plus c. Now, to finish that off, it's going to be the square root of x cubed, all right? Now, this times by 2 over 3, what I can do just to make this simpler, 2/3 of that, I'm going to just plonk, a 2 out in front of here and put it over 3 plus c, all right? And that looks a bit more simpler than this one, and that's why we kind of do it like that. Okay, please, if you have any questions, fire them to me now. I'm going to upload this at the time we have class tomorrow. Sorry again about the live stream going so bad. But I actually think in a way putting these videos up, it's better because I know some of you for different reasons might not be able to tune into the exact time like the live stream, and I don't know how to record the live stream. So yeah, I think in a way it's good that you can then catch up with this. Okay, any questions, fire them to me, please. I hope you're able to see that and hear me okay.